In this next problem, we are given a different type of clue. We are given a point that the ellipse itself passes through. Now let's start by drawing a quick graph, and we notice the vertices are 13 units above and below the origin. So I'm going to draw a quick sketch here and put my vertices up at positive 13 and down at negative 13. This other point here, 25/13, 12, will just be a little bit to the right and below that upper vertex. So you can see from this sketch that we are going to have an ellipse looking kind of like what I have right there. We don't know how wide it's going to be, but we know it's going to go through those 3 points. Based upon the vertices here, we know that the center will be halfway between them at the origin, and that tells us that our equation of the ellipse will be of the form x squared over something plus y squared over something is equal to 1. And that second something beneath the y squared is going to be 169, which is 13 squared because we had gone up and down 13. Now, since the value of a is the distance from the center to the vertex, we know that the b squared is what's beneath the x squared and is what's missing in this equation. The trick to opening up this problem is to realize that the curve passes through this point, and therefore that this point satisfies the equation of the ellipse. Therefore, if I substitute these values in for x and y, we'll have an equation that we can solve for b squared. So let's do just that. Instead of x squared, we are going to have 25 over 13 squared all over b squared plus y squared, which becomes 12 squared over the 169 equals 1. Now we need to solve this for b squared. Now we just have a little bit of algebra. Let's clean up what we have here. We have 625 over 169 all over b squared plus 144 over 169 is equal to 1. Now we can solve this equation in a variety of ways, but I'm going to choose to multiply through by the least common denominator, which is 169b squared. On the left, the b squareds cancel, and we have 169 times the fraction 625 over 169. In the second fraction, the 169's cancel, leaving b squared times the 144. And on the right, there's nothing to cancel with, so we multiply 1 by that least common multiple and have 169 b squared. Upon subtracting the 144 b squared on each side and simplifying the fraction on the left, we now have 625 equals 25b squared. Well, dividing each side by 25 gives you 25 is equal to b squared, and that is the missing denominator we were looking for. Therefore, the answer to this problem, or the equation of the ellipse we're looking for, is x squared over the b squared value of 25 plus the y squared over 169 is equal to 1. Now let's look at another feature of an ellipse known as the eccentricity. As you well know, ellipses come in a variety of shapes and sizes. We can have the long skinny ones, or we can have the ones that are more circular in nature. Let me draw the center into each of those two sketches there. In the one that is more elongated, the value of c is larger, and the foci are further away from the center. As the ellipse becomes more and more circular, the foci get closer and closer to the center. Now, E is going to be known as the eccentricity, as you can see just as I've got it written up there. C, as you know, is the distance from the center to the focus, and A is the distance from the center to the vertex, or to either one of the vertices. Now, the fraction c over a is between 0 and 1. And as it is closer to 0, that is when the ellipse is more circular. It's not a circle yet, but it's more I can spell circular. And as the value of c over a is closer to 1, then this is going to be more elliptical in nature. It'll be stretched out. Now let's see why that's true. When it is more circular, the value of c is smaller compared with the value of a, and so the numerator is a lot smaller, and up in this elongated picture, the value of c is much larger compared with a, so that fraction is closer to 1. So this eccentricity is just a way of describing how stretched out or elongated an ellipse is by just looking at this number, or this ratio, c over a.